All right, very last video for section 7.1. So we're in 7.1, adding and subtracting polynomials. We're going to actually get to that last bit. In part 1, we found the degree of the monomials. Part 2, we classified polynomials. And this last one, we're finally going to add and subtract polynomials. So first, we need to talk about what it means to be closed. A set of numbers, what we mean by closed mathematically, is a set of numbers. A set of numbers is closed under an operation. What we mean by operation, mathematically, we have 4 operations: add, subtract, multiply, divide. Is closed under an operation when you perform the operation and also get a number in the set. What this means is if I add fractions, I'm going to get fractions out. So addition is closed over fractions. So for fractions, addition is closed. Meaning if I take a fraction and add another fraction, I get out a fraction. Mathematically, we refer to these as rational numbers, not fractions, I guess. So we'd say rational numbers, anything that can be written as a fraction. So when I take fractions and add fractions, I get fractions back out, okay? But that doesn't work, let's say, for whole numbers and division. If I take a whole number, our whole number is the number 0, 1, 2, 3, 4, ... And if I divide them by other whole numbers, I don't always get whole numbers out. Meaning if I took 8 and divided it by 3, I don't get a whole number out. So division is not closed. Okay, division is not closed over the whole numbers, because I can't always divide and get other whole numbers. But it is over addition, subtraction, and multiplication. Because if I multiply whole numbers, I'll get whole numbers. Okay, if I subtract whole numbers, I'll get whole numbers. Okay, so division is not closed over the whole numbers, but it is closed over fractions. If I divide fractions, I'll get fractions back out. Okay, so closed just means that I can do it within the set and I'll always get stuff out for the set. Addition and subtraction are closed for polynomials. If I add 2 polynomials, I'm going to get a polynomial out, okay? But one word of caution, when adding polynomials, you add like terms. So to find the sum and add, I add like terms. What we mean by like terms is they have to have the same variable part. So I really like to color code here. So here, if I've got a 2x to the third, I'm taking this polynomial here. 2x to the third minus 5x squared. Again, I'm going to come in and right away write that as plus a negative. Write that one as plus a negative. And I'm adding it. So I'm taking this polynomial here, adding it to this one here. The only way I can simplify that is by putting together like terms. So this 2x to the third, I can only add it to other x to the thirds. I've got 2 of them here, 2x to the thirds. I've got 1 of them here. So I would have 4 of them total, but they're still x to the thirds. The variable doesn't change. They still are what they are. Like they're still x to the thirds. I just have 2 of them. Oh my. Ooh, it's not 4, it's 3, guys. Sorry. 3 x to the third. I have 2. I'm adding 1 more. I now have 3x to the thirds. And since we like to leave our answer, we want to leave our answer in standard form, I always start by adding the terms that have the highest degree. So x to the third has the highest degree. So next here I have negative 5x to the second, and I'm adding a 2x to the second. So I have negative 5 of them here. I have 2 of them here. Well, negative 5 plus 2 is negative 3, so that'd be subtract 3. But these are still x to the seconds. Okay, I just had negative 5 of them there, 2 of them there. So total I have negative 3x to the seconds. Okay, and now next I'd go to the next term, which is just a straight up x. Well, there's no x's over in this one anywhere, so I just have plus x. And then last, here I have this minus 1 here. It's a negative 1. But now there's nothing else I can do to these because these are not like terms. This is x to the third, this is x to the second, this is x to the 1. I can't put them all together and have x to the, I don't know, 6th or something. Okay, I can't do that because they're not alike. Okay, you can only add things that are alike, meaning I can't take 2 cats plus 3 dogs and say, okay, now I have 5 cat dogs. Dogs? I don't know how I'd write that. That does not work. I still have 2 cats and 3 dogs. Okay, I can't put them together and write them as, okay. And that's a very common mistake. Often we'll take 2 C's plus 3 D's and I'll have people write, well, that's 5 CDs. No, it's not 5 cat dogs. That does not work. You can't add these, 1 C's, 1 D's. Let's go ahead and look at another one. Again, we're adding, so we can only add like terms. Okay, so I am going to start with my 3x to the second in that first one and look to see, do I have it? Am I adding any other x to the seconds? I do. I have one there. So I've got 3x to the second, one more here, so I have 4x to the seconds. Okay. Now let's go with my x's. So here I have 1x, that's 1x and 4 x's. I'm adding from there in the middle. 1x plus 4x is 5 x's. Oh, I forgot a step. I need to come in and change all these plus negative. Oh, I only had the 1, I guess. Okay. And then last, I've got negative 6 plus the 10 is positive 4. So I have 5x to the second plus 5x plus 4. I want to make sure none of these are alike. Nope. So there is my final answer right there. 5x squared, 4x squared plus 5x plus 4. Okay. Now, subtracting. It's important to notice when adding here that we are adding all of them. I'm adding this, I'm adding this one, I'm adding this one. This addition gets applied to all of these. That is the same with subtraction. This subtraction is getting applied to all of these. I'm subtracting all of these. So, to help, I will tell you, you guys, if you don't do it this way, you are guaranteed to make sign mistakes. I'm going to rewrite this as adding a negative. So this negative now goes to each of them. So my very first step is going to be writing this as plus and then applying this negative to each of these. So I have the negative of negative 2n, which is going to be positive 2n to the second. Then I have the negative of this 2n, which is going to be plus a negative 2n. And then this is plus a negative 4. So I have the negative of this negative 4, which is positive 4. Okay. And then I'm just going to write this first one down as is. So now I'm taking this. So now what I did is I turned the subtraction problem into an addition problem. Please do it this way. It'll save you tons of sign error. So now I just do it like we did our previous problems. It's got one extra step, and then I just do it like I'm adding. So 4n to the second plus 2n to the second, I'm going to have 6n to the second. Okay, now let's see, I've got a positive 5, but I have a 2n here. So let's go ahead and add 2n, but I don't have any n's here, so we'll just have that plus 2n. So it's a negative 2n, so we'll write it as minus 2n. And then now we have the number bit. We've got the plus 5, the plus 4, which gives me plus 9. So we have 6n minus 2n plus 9. So there's our difference. Again, I'm always starting with that first step. Okay, so my very first step is to rewrite all of these as plus negatives, plus negative, plus negative, plus negative. And then I'm going to apply this negative to each of those. So I'd have plus, and then I'm going to have negative 3x to the second, the negative of negative x, which is positive x, and then the negative of negative 8, which is positive 8. And now I'm just adding plus a negative 3x plus 5. So now find like terms. I've got 4x squared, negative 3x squared. 4 and negative 3 is 1, so I would have 1x squared. Negative 3x plus x, that's 1x. Negative 3 plus 1 is negative 2. And then I've got positive 5 and negative 8. 5 plus 8 is 13. Positive 13. So there I am, all done. All right, so your very last set of problems, page 362, 1 through 4, Do these right here. Again, do these at Big Ideas Online.